Hello, I'm Dr. John Mercer, and in this presentation, I am going to talk about some research that we've done at the University of Nevada, Las Vegas on swimming in warm water and whether or not there are core temperature consequences of wearing a wetsuit, specifically a triathlon wetsuit. This presentation is a result of some work of some students, Lena Swafford, a doctoral student, Caitlin Conroy, a master's student, and Borm Lin, also a doctoral student. We've worked on this project over the past year, plus some pilot work I'll talk about and uh, share with you some data on swimming in a wetsuit. So I am really interested in triathlon performance. Now, there's a lot of factors that influence triathlon performance, from biomechanics, macronutrients, sweat rate, glucose, force. There's a lot of different things that go into understanding human performance. And in triathlon, we have to apply all these factors to swimming, biking, and running. We need to look at the interplay between these events, how swimming influences spiking, how biking may influence running, and what have you. We also have to look at the transitions that happen between each of these sports. And again, looking at all these different factors to really understand triathlon and ultimately what influences performance. Now, for this presentation, I'm going to zero in on the swim portion of the event. And I'm really interested in how the wetsuit influences performance. Now, there's a lot of factors that influence swim performance, and this is not an exhaustive list, but just some that I want to highlight for this presentation. Swim performance is going to be influenced by environment, the water temperature, which is what I'm going to talk about today, the air temperature, the wind, the water conditions, waves, current, even visibility in the water will all influence swim performance. Even the sun provides radiant heat to the swimmer when swimming outside. It also can either help or interfere with the ability to sight, that is, the ability to swim straight in open water. Now, the wetsuit really plays a role in biomechanics of swimming, from providing additional buoyancy in addition to the buoyancy the swimmer provides due to their morphology or their body composition. And really, the wetsuit is going to influence the drag force of swimming. That's our equation for drag force. And the wetsuit, putting the wetsuit on is important, and the design of the wetsuit is going to be important. So we're going to talk about wetsuit design and wetsuit fit as it relates even to swimming and core temperature. Some other work that we're doing is looking at the influence of wetsuit design on muscle activity during swimming, especially the shoulder movements. But the other area that I'm interested in with looking at wetsuits is the physiology of swimming in a wetsuit, and more specifically, thermal regulation. Now, from a biomechanics lens, the wetsuit we know can improve swim performance. And specifically, it does that by reducing the drag resistance force. Drag resistance force equation is there, 1/2 rho CdAv squared. And really the wetsuit is going to influence the CD, the coefficient of drag portion of this equation. But the buoyancy force also lifts the lower extremity and puts the person in a better swim position. And that can actually reduce the A, the frontal area portion of the resistance force here for swimming. But I want to, for this presentation, zero in on the physiology of swimming, and even more so the thermal regulation aspect of swimming. So this is a model, sort of a big picture model of human performance. And simply describes that human performance is a function of taking chemical energy in the body, or fats, or carbohydrates, and transforming that chemical energy to mechanical energy, a force applied over some distance, over some time. And that force is what allows us to move. Now, when we create a force, we have to create the right amount of force, apply it at the right moment in time. We need to coordinate muscles to generate forces relative to each other. There's a lot that goes into this. Uh, but the transformation of chemical energy to mechanical energy, we know is not 100% efficient. In fact, it's probably only a third efficient to generate mechanical energy from chemical energy, maybe even less than that based upon coordination or movement skill. So when we have chemical energy and we transform it to mechanical energy and it's not perfect, we have a release of other type of energies. In this case, it's going to be heat. And there's a lot of heat that's generated through movement. Well, a wetsuit is designed to retain that heat and keep the person warm. And really, the wetsuit came about by through triathlons, um, in competing in ocean water or lake water that was really cold. And so, by wearing a wetsuit, the athletes had the ability to complete a swim and then transition to the bike and ultimately the run and have a successful race. But without that wetsuit, they would run the risk of getting hypothermic or too cold. So the wetsuit is really designed to retain heat. Now, there's rules that have to be followed in triathlon, and these rules specify when a wetsuit is mandatory that you have to wear, or when the wetsuit's optional, and then when the wetsuit is not allowed at all. And these are all temperature based, but the temperature ranges here change based upon level of athlete as well as distance, and even which governing body is overseeing the particular race. So here's USAT, this is USA Triathlon, this is International Triathlon. There are different rules for different organizations, and athletes really have to pay attention to those rules. Now, I've highlighted these in red. These are the upper limit of when you cannot wear a wetsuit. And the idea is that you're probably going to get too warm, or that's the hypothesis. Now, there's in green is the mandatory. You have to wear a wetsuit in order to retain that heat and stay warm and be able to successfully complete the swim. And that's one of the iconic races, Norseman. Uh, the water temperature is usually below 15 degrees Celsius, and you have to wear a wetsuit and maybe even some other warm gear while you're swimming. But I'm interested in the what happens at the higher end of that spectrum of temperatures, and in particular, how a wetsuit may may influence core temperature of the swimmer. Now, what do we know about swimming in warm water? Well, when you swim without a wetsuit in warm water, you will swim slower. The work that has been done on measuring core temperature while swimming in warm water has indicated that the changes in core temperature are relatively modest, less than a degree Celsius change swimming in warm water. I'll go through some of that information. Now, there is some research on swimming in water, in warm water while wearing a wetsuit, but there's very limited research. In fact, these studies really describe the scope of work in this area, and this is the same research group. Trapp and colleagues looked at wearing a wetsuit and swimming in 25.6 degrees Celsius water for 30 minutes, and the change in core temperature was 0.89 degrees Celsius. Very modest change in core temperature. And then another study that they did, there was no change in core temperature when comparing the no wetsuit versus the wetsuit condition swimming in 30 minutes in 25.6. So very subtle changes or modest changes or no changes at all while wearing a wetsuit when swimming in warm water. Now, what's interesting is the work done back in the 90s was using rectal temperature, which is really the gold standard for core temperature. But it's limited in how often you can record those data, especially during swimming. So you're limited to really measuring core temperature before the start of the swim, at the end of the swim. And if you measure it during the swim, you need to get the swimmer out to be able to measure core temperature using that technique or that instrument. More recently, there has been an ingestible pill system that allows to continuously record core temperature at a sample rate of even one sample every 10 seconds. And so that's a way to re-examine this understanding of core temperature when swimming in a wetsuit and get a little more finer detail or picture of what's happening with core temperature. The other issue to consider when looking at the literature is using an experimental model where subjects were asked to swim a particular time, for example, 30 minutes, versus a distance. Swimming for time is a little bit more challenging mentally than swimming a distance. And there may be different outcomes of a study based upon the type of model that the experiment's going to use. Now, we've done some pilot work on using a fixed distance and having swimmers swim in wetsuits and without a wetsuit. And we had subjects complete a 500-meter swim in 25.5 degrees Celsius water, and they wore a full sleeve wetsuit for one 500 meters. Then they wore a sleeveless wetsuit for another 500-meter swim, and then a no wetsuit condition doing the same 500-meter swim. And interestingly, we looked at average core temperature during those swims, and there was no change in core temperature, which was really interesting. And what we took a step back and we thought, well, maybe the swimmers didn't swim far enough. Maybe we need to have a longer swim, or maybe the intensity wasn't high enough, which leads me to the study that I'm going to talk about here. And the purpose of this study was to determine if core temperature was influenced by wearing a wetsuit during warm water. With the distance now being 1,000 meters, warm water is still 25.5 degrees Celsius, and the intensity was more aligned with a race pace for a half, a 70.3, or even a full Ironman. All right, so we took five triathletes, and three males and two females, and we had them take a core temperature pill the night before testing, and we set the sample rate to one sample every 10 seconds. And we did just use one wetsuit in this case. We used just a full sleeve wetsuit because we're having them swim two 1,000 meter swims. And the two conditions were no wetsuit or full sleeve wetsuit. They were swam on the same day. We did provide rest between conditions so that core temperature came down to half a degree Celsius of baseline prior to starting the second condition. Water temperature was 25.5 degrees Celsius. The order was randomized. And the intensity was, we used descriptors like somewhat hard, but similar to a race pace for a 70.3 or an iron distance type of race. The measurements we took were based upon core temperature tracings. This is the temperature on the y-axis. This is time on the x-axis. And this is one sample of data from one swimmer in one condition. We calculated average core temperature for the duration of the swim. We calculated the delta core temperature between the end of the swim and the beginning of the swim. And then we calculated the rate of change of temperature between the maximum temperature and the starting temperature. We also looked at 1,000-meter swim time and also calculated stroke rate. Here's the data. On the y-axis here is time, and on the x-axis is the condition. This is the no wetsuit condition, the wetsuit condition, and this is the time to complete 1,000 meters. 912 seconds here for the no wetsuit, and shorter time for the wetsuit condition. So about 15:12 on average for the group, and under 15 minutes for the wetsuit condition. So about a 6% improvement of swim time when wearing the wetsuit. And this was different, or these swim times were different. The range of improvement was a minimum of 1% and as much as 10%. Every subject improved their swim time using the wetsuit. These are the average speeds for the group. Here's the stroke rate data. Stroke rate in hertz on the y-axis, the no wetsuit condition and the wetsuit condition. No change in stroke rate. No change in stroke rate. Here's the average core temperature on the y-axis. No wetsuit condition. For the 1,000-meter swim, there was no change in average core temperature. Here's the change in core temperature, just the delta temperature. This is delta temperature here. And for the no wetsuit, there was a 0.54 on average change in core temperature. And for the wetsuit condition, 0.28. There was no change in core temperature dependent variable. So change in temperature was not influenced by the wetsuit condition. Rate of change of temperature was also not influenced by the wetsuit condition. Here's the no wetsuit and the wetsuit condition, no change in rate of change of temperature. So this was getting interesting just looking at the group data. But since we had 5 subjects, we wanted to look at the individual responses as well. And knowing that individuals can respond differently to different wetsuits and swimming in a wetsuit, we really wanted to dive into this a little bit deeper. So here are the data for each subject. So this is temperature on the y-axis. Well, I've normalized the data to 100% being the starting temperature. This is time down here on the x-axis, and these are the different subjects and the genders of the different subjects. And you can see in general, all these subjects tended to increase core temperature throughout the swim, except for this subject right here. Something odd happened. And even in subject 4, something odd happened here, maybe even a little bit funny thing here with subject 3, they're jumping in and the core temperature is going down initially, and then it starts to rise upwards. Here are the data for swimming in the wetsuit condition using the full sleeve wetsuit. Now, in general, all these subjects ended up with a higher temperature at the end of the swim. But something really interesting is happening back here in the beginning portion of the swim, where the core temperature is really not changing up until about halfway through. And then the core temperature starts to go up for these subjects. Subject 1 did something interesting here, and subject 4 again has done something interesting here as well, where core temperature is actually dropping initially, and then it starts to go up near the end. So given these individual responses, we wanted to dive a little deeper and look at some additional parameters. And we looked at the starting temperature. It was not different between the wetsuit and the no wetsuit conditions. We looked at the minimum temperature. So minimum temperature that we'd see anytime during the 1,000-meter swim. There's no change in minimum temperature between the full sleeve and the no wetsuit condition. We looked at the maximum temperature. So just going in and finding wherever the max occurred, which tended to be at the end point. But in the case of this subject here, subject 3, max temperature occurred prior to the end point, and maybe even with subject 1 here as well. Max temperature was not different between the conditions. And finally, we looked at the temperature increasing per condition, because again, all subjects were ending above the starting temperature. In that case, the temperature for each condition did increase. So for the no wetsuit condition, temperature increased over the 1,000-meter swim. For the full sleeve condition, temperature increased for all subjects by the end of the swim. But the change in temperature was not different between the conditions. So we considered that maybe something was going on with pace of the swimmer. So we looked at the pace and we actually recorded the 50-meter splits for each swimmer. So here's subject 1, 2, 3, 4, and 5. This is the 50-meter time on the y-axis. This is distance on the x-axis. The thick line being the wetsuit condition, the thin line being the no wetsuit condition. And when looking at these, we don't see any really strange changes in pace throughout the swim. Maybe something funny happening here with subject 1, maybe even subject 4, something here. But in general, they did a good job of even pacing the swims across the entire 1,000 meters. So no real dramatic changes in intensity, as evident by the pretty consistent pace that we saw during the 1,000-meter swim. All right, so what's going on? Well, going back and looking through literature, there are some other examples of looking at core temperature swimming in warm water. And here's some data from a research team, Bailett and Hute, where they looked at core temperature swimming in a half Ironman race. They looked at 19 athletes in 29.5 degrees Celsius water, but this was a no wetsuit legal swim, so their athletes did not wear wetsuit. But no change if any, change is very modest between pre-race and post-race. So these were measurements taken right before the start of the swim, and then as the as the athletes came out of the swim and were transitioning, they were able to record the temperature again. So really no change in core temperature, or zero point 0.7, uh, less than a degree Celsius change for core temperature. Here's some additional data. Again, no wetsuit, swimming in a flume at 32 degrees Celsius and swimming different times. So doing a 20-minute swim, a 60-minute swim, and a 120-minute swim. The swimmers reached the same core temperature for each of those conditions, even though they were in the water for almost 2 hours versus only 20 minutes. The change in core temp was 0.75 to zero point 0.9, so a bit higher than the present study. Now, maybe that is due to length of time, because we did not see our data plateau. Our data at the end for all subjects were pretty much increasing core temperature. So I don't know what would happen if we had the swimmers continue to swim. It might have continued to go up and plateau. We don't know. But what we do know is, so far, the data collected on swimming in warm water with or without a wetsuit is there's even either no change or very modest change in core temperature. Again, these are for swim conditions where the swimmer is selecting their own pace. And that might be something really important to consider. So what is going on here? Well, one hypothesis is that the brain is regulating or core temperature, and the body is trying to stay within a homeostasis region, or a narrow region of core temperature. So maybe there's a thermostat that the brain is detecting and monitoring. And are swimmers selecting a pace to minimize influence on core temperature? Again, our study and other studies I've reviewed, swimmers are selecting their pace. It's not set for them. And so maybe that perception of core temperature is driving a particular intensity, because we know intensity will influence core temperature. The harder you swim, the more chemical energy you're transforming to mechanical energy, and the more heat you're generating. But this brings us back to the ability of swimmers to perceive temperature. And there needs to be some more work in this area. And maybe skin temperature is more important for perception than core temperature. Something to look at. Now, the other thing to consider is, maybe it's an experimental problem that we're having here with trying to measure core temperature while swimming in a wetsuit. Our study was done in a pool. And that means the swimmer needs to, do a turn every 25 meters. Wetsuits aren't really designed for flip turns or even doing open turns and pushing off the wall at a high velocity. There's a tendency for water to get inside the wetsuit. And so maybe what is happening is cooler water is entering the wetsuit, and the body heats up that layer of water in the wetsuit, but then you hit a turn, and maybe more cooler water gets back in the wetsuit. So maybe this is an experimental problem that we're having versus actually measuring what is going on. So we need to replicate this study in a flume, or even go and do this in open water. The wetsuit fit is a big issue. Even though our triathletes were experienced in using wetsuits, everyone fits into a wetsuit a little bit differently. And it does take time to get the wetsuit set correctly so that the person has pretty free or unrestricted movements within the wetsuit. And different body types require different types of wetsuits. We were really focused in on limited types of wetsuits here. Swimmer morphology may be an issue. Body composition of each swimmer, we want to look at that a little bit more. How much body fat each person has, and how that wetsuit may perform differently for people with different amounts of body fat. Swimmer technique and or ability may be a factor that we need to account for. It may be that our faster swimmers will have a different type of response than our middle of the pack or even back of the pack swimmers when using a wetsuit. And that leads to swim time and even pacing strategies that may influence the outcome of the study. So again, we need to do the study in a flume to be able to replicate the data or to come up with a different picture of what may actually be going on. But based upon what we have done to date and looking at the literature, the conclusion is that wearing a wetsuit during a 1,000-meter swim in 25.5 degrees Celsius water at a self-selected pace resulted in modest changes in core temperature, less than 1 degree Celsius change. And the change that we saw for the wetsuit condition was no different than the change in core temperature when swimming without a wetsuit. Now, it's also important to note that the subjects did swim faster with the wetsuit versus the no wetsuit condition, about 6% faster. And it may be that swimmers are selecting a speed that minimizes the influence on core temperature. And we're just going to need to continue to look at this project or look at this question a little bit further to try to tease that understanding out. So thanks to the students who are involved with this project, a lot of them have explored participating in a triathlon, which is exciting, either as a relay or as an individual. And some of them are training for their first triathlon coming up. So thanks for listening and hope that was helpful.